molecules. In the last class, we discussed about the temperature dependence, the temperature effect on the rate of the reaction, and catalyst effect on the rate of the reaction. And the last topic of this chapter is collision theory. Collision theory. So what is this collision theory means? Listen, if any reactants they react with each other to form product means they have to collide with each other. So collision is greater in gaseous molecules rather than liquid, rather than solid. Okay? Because in the gaseous molecules the atoms are randomly arranged, they can easily move from one position to another position, they can easily collide with each other. But in solid they are stiff at their position. There is no free movement of the atoms in the solid state. Okay, that's why they cannot react with the other molecules to react easily to produce products. So collision is more in gaseous products rather than in liquid than in solids. Okay, so in that one equation is there that is explained by the Lewis. So reactants A plus B is there. They react with each other to give products. When they will react? When these two gets collide with each other. How? So initially the bond is in between A and A. Here it is in between B and B. Okay. So these A and B, when they collide with each other, then only the product will form, that is AB. Okay. So that means these reactants should orient in a proper direction. This reactant molecule should be oriented in a proper direction in such a way that the bond between this A and B gets break, and A and B and B gets break, and the bond between A and B should form. Understand? So to collision, what is the main condition? These reactant molecules should be oriented in a proper direction. So which direction it is? The direction in which the bond between the same atom breaks and the bond between two different atoms forms. Understand? So that is called as collision. So this collision is explained by the equation rate is equal to ZAB divided by ZAB into e to the power of minus EA divided by RT. Okay, rate is equal to ZAB e to the power of minus EA divided by RT. This one is collision frequency. And this one is fractional molecules. Okay, so this one is collision frequency. What is collision frequency? The number of collisions per second per unit volume. Okay, so number of collisions per second per unit volume is called as collision frequency. Understand? So this collision frequency is certain. So this reaction, this equation 1 is compared with the equation K is equal to A e to the power of minus EA divided by RT. Students, in both the case, these two remain same. So number of collision frequency also equal to what? Arrhenius constant. Okay, so the collision frequency in the reactive species is also equal to the Arrhenius constant. Okay, so this is all about the collision theory. So in this collision theory, students, these reacting molecules should possess a minimum or a sufficient amount of kinetic energy to form a products. That kinetic energy is called as what? Threshold energy. Okay, so this collision, what is that? To undergo effective collision, it requires activation energy as well as threshold energy. What is the threshold energy? A sufficient amount of kinetic energy required to get collide. Understand? That is called as what? Threshold energy. If that type of energy is there, then the effective collision will form. Okay, if the effective collision will form, then the product formed is more. Okay, the first condition is it should have the minimum amount of energy, sufficient amount of energy, that is called as threshold energy, and also it must have a proper orientation. Okay, to form a bond between the two different reacting molecules. Okay, so this is all about the collision theory. So this completes the chapter theoretical part. Okay, so next one is problematic. We will discuss with the problems one by one. So in this, what you have to remember, one is what is collision frequency and equation of collision frequency. So we will discuss the problem. First one. The decomposition of N2O5 in CCl4 at 318 Kelvin has been studied by monitoring concentration of N2O5 in the solution. Okay. Initially the concentration of N2O5 is 2.33 mole per liter, and after 184 minutes it is reduced to 2.08 mole per liter. The reaction takes place like two into O5 gives rise to 4NO2 plus O2. So calculate average rate of reaction in terms of hours, minutes, and seconds. And what is the rate of production of NO2? What is the rate of production of NO2? Okay. Listen dear students, the decomposition of N2O5 in CCl4 at 318 Kelvin has been studied by monitoring concentration of N2O5 in the solution. Initially, concentration of N2O5 is 2.33 mole per liter. After 184 minutes, it is reduced to 2.08 mole per liter. The reaction takes place in this manner, so then calculate the average rate of a reaction. Okay, so the first thing we have to follow here, average rate. So first I write given values here. Okay, so what are the values given here is R naught they given, initial value that is 2.33 mole per liter. Final value they given are that is here 2.08 mole per liter. Time they given how much here 184 minute. Okay, so you have to calculate first average rate of a reaction. So average rate of a reaction is equal to, if you write this students, this must be 1 by 2 delta N2O5 divided by delta T. This will be minus. Why? Because this N2O5 is a reactant. Understand? Then we will get 1 by 2. Okay? So here R naught value, this N2O5 means R minus R naught divided by delta T. Correct? So that is equal to how much? 1 by 2. R means 2.08. R naught means 2.33 divided by 184. Okay, so we will get 1 divided by 2 is 2.08, 2.33 means minus 0.21 divided by 184. So approximately students will get 6.79 into 10 to the power 4. 6.79 into 10 to the power minus 4 mole per liter. I take mole per liter per minute. Mole per liter per minute. If it is a mole per liter per minute, what is this? This is a first order reaction. This is a first order reaction. Correct? So listen, here they are asking in terms of hours, minutes and seconds. Correct? So in minute, it is how much? 6.79 into 10 to the power minus 4 mole per liter per minute. Correct? In second, what you will do to convert it into second? Multiply by 60 or divided by 60? Multiply by 60. So 6.79 into 10 to the power of minus 4 into 60 mole per liter second inverse. Okay? Next, in hour, what you will do? Divided by 60. So that is 6.79 into 10 to the power of minus 4 divided by 60 mole per liter per hour. Okay, this is the answer in terms of minutes, seconds and hours. Again they said students, what is the formation of, here, rate of production of NO2 they said. Okay, I hope you did that. Second one is rate of production of NO2. So by comparing with these students, this is equal to what? 1 by 4 times of concentration of NO2 by time taken or delta T. That is equal to what? This much. Correct? So 1 by 2 delta T into by delta T is equal to this much. So that is equal to how much? 1 by 4 times of by comparing these two, I take minus 1 by 2 delta into O5 divided by delta T is equal to 1 by 4 times of formation of NO2 by delta T. Correct? By comparing with these two, rate of a reaction, we will write it like this. So 1 by 2 of reactant, that is change in concentration of N2O5 by change in time, and is equal to 1 by 4 times of change in concentration of NO2 divided by change in time. This is the reaction I take. Okay. This complete value is how much? 6.79 into 10 power minus 4. So 6.79 into 10 power minus 4 is equal to 1.4 into NO2 by T3. So if it is cross multiplied, you will get the formation of NO2 by T3. Understand? So I write here delta NO2 by delta T is equal to 6.79 into 10 to the power of minus 4 into 4. You will get the answer. Understand? So this is next. Second one. For the reaction, R tends to P, the concentration of reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Calculate the average rate of reaction using units of time. Using units of time in minutes and seconds. Okay. So students, here the given value I will write first. R naught they given 0.03 molar and R they given 0.02 molar. Time they given 25 minutes. Initial is 0, final is 25 minutes. This is delta T. Okay. So reaction they given R tends to V, and then we want to write delta R by delta T is equal to change in concentration of R minus R naught divided by delta T. R is how much? 0.02 minus 0.03 divided by 25. So that is minus 0.01 divided by 25. So students, if we shift this power here, 1, 2. Okay. So that is minus into minus plus 1 into 10 power minus 2 by 25. Now it may simply take, if you made it into 100, then it is 10 to the power of minus 4 by 25. That is 4 into 10 to the power of minus 4 mole per liter minute inverse. Understand? I moved 4 digits. So I shifted this decimal point 4 digits forward. That means 10 raised to minus 4. Okay? It is 4 into 10 to the power of minus 4 mole liter inverse minute inverse. So here this side in minute, in second. So in minute it is 4 into 10 to the power of minus 4 mole liter inverse minute inverse. Okay? So in second what happens? In second it is multiplied by 6. That is 4 into 10 to the power of minus 4 into 60 mole liter inverse second. That means 24 into 10 to the power of minus 3 mole liter inverse second inverse. That is the reaction. Understand? So this is another flow. So next one is 5 OMR students. I'll write it on board. I'll write only question here. Do it yourself. In a reaction, 2A chain gives rise to product. The concentration of A decreases from 0.5 to 0.4 mole per liter in 10 minutes. Calculate the rate Next one. Following data were obtained during first order thermal decomposition of N2O5 at constant volume. So the given data is 2N2O5 gives rise to 2N2O4 plus O2. So initial data is when it is 0, when time is 0, total pressure is 0.5. When time is 100, then this is 0. Time in seconds, this is 512. Calculate rate constant. And right here, calculate rate constant. Here, given unit. Okay. So for a first order reaction, they given the certain values at 0 second, it is 0.5 pressure. At 2, trial number 2, at 100 second, it is 0.512. Okay. So students here, first you have to consider this reaction. That is 2N2O5 gives rise to 2N2O4 plus O2. So initially it is time K is equal to 0. So it is 0.5. This is 0. This is 0. After time 100, this becomes 0.5 minus 2x. Okay, this one is 2x, this one is 2x. Okay, students. So from this we have to, this we are taken in what? Pressure. That is P total. Okay, so P total is equal to P of N2O5 plus P of N2O4, this one, plus P of O2. This is the pressure, correct? P of N2O5 is 0.5 minus 2x. So P of N2O5 means 2x. P of O2 means 2x. This will get cancelled, means that is 0.5 plus 2x. What it is? P total. P total is equal to that much. Okay. So from this, students, we can easily calculate this. P12 is equal to 0.25 plus 2x. Then P of N2O5 is equal to this one. Okay? 0.25 minus 2x. Correct? So from here we can easily calculate x is equal to Pi minus 0.5 divided by Sorry, this one is x moles because this is 2 moles 2x, this is 2 moles 2x, this is x mole. Correct? So we will get 0.5 plus x. Then x is equal to what? Pt minus 0.5. Correct? X is equal to Pt minus 0.5. So here total pressure of N2O5 we have 0.5 minus 2x. What is x here? 2 into Pt minus 0.5. If you calculate that, students will get 2 Pt minus minus plus 1. Correct? That is 1.5 minus 2 Pt. This is pressure of N2O5. So here I mentioned that is what? First order reaction. Rate constant for a first order reaction is K is equal to 2.303 by T log of. If you want to take it in a pressure, that is R0 by R. Correct? That is initial pressure. So what it is? PA by P. Okay. So K is equal to 2.303 by T log of. Initial pressure here is 0.5 divided by final is P of N2O5 1.5 minus 2 Pt. Correct? So if we solve the students, we will get, this is approximately another one they given at time t is equal to 100, the pressure is 0.512. That is given value, right? So students, in the question you take at t is equal to 100 seconds, pressure is equal to 0.512. Okay, sorry. So then, if you minus this 1.5 minus 0.152, you get 0.476. Okay, this value. 1.5 minus 2 into 0.512, you will get 0.476. Okay, so listen here. K is equal to 2.003, time is 100, log of 0.5 divided by 0.4. So this is approximately 0.018. Zero point 183 or 19 approximately. 1, 2, 4 ones are 4, 10 left, sorry. Again 1, 9. 0.119 approximately you can take. Okay. So students, here, log of 0.119 from the logarithmic table you have to see. So this is 11 under 9. Okay, so these vertical lines are there. Here we have to choose 11, from here 9. So this value we have to choose from the logarithmic table. We will get 2.303 by 100 into the approximate value is 0.016. 0.0216. That is, this value is from what? Log table. Okay, so log table is in the horizontal, that is 11th row, in the vertical, that is 9th column. Okay, if you check, you will get 0.0216. Understand? So if you multiply this, you you will get the answer 4.98 into 10 to the power of minus 4. 4.98 into 10 to the power of minus 4. As it is a first order reaction, it is second inverse. As it is a first order reaction, it is second inverse. So this type of question, they'll ask in only neat seat. Not this much, only this comparison. Okay, how many moles will form like that. Understand? So this is another problem based on rate of a reaction. So students, this rate of a reaction problem, especially based on this atmosphere, gaseous pressure is not that much important. But this is given in NCERT, that's why I am doing it. Okay, this is not that much important. Next one is first order reaction is found to have a rate constant K is equal to 5.5 10 to the power minus 14 second inverse. Find the half-life of the reaction. Find the half-life of the reaction. Okay, students, here. Listen. Here the given K is equal to 5.5 into 10 to the power of minus 14 second inverse. So we know half-life for first order reaction, that is PR is equal to 0.693 divided by K. This is the equation for a half-life period of a first order reaction. So this is 0.693 divided by 5.5 into 10 to the power of minus 14 seconds. Okay, so here 5.5 is there, here 6.9 is there, approximately it is 0. I'll shift the point here. That is 6.93 into 10 power minus 1 divided by 5.5 into divided by 5.5 into 10 to the power of 14. Correct? So this is approximately 1.1 into 10 to the power of 13 seconds. 1.1 into 10 to the power of 13 seconds. 1.1 you can use calculator in the examination, so you can easily calculate. So this type of half-life period and first order reaction equations are examples and problems are important for 2 months. It is compulsory based on first order reaction. Okay, either they will give rate constant, they told you to calculate this, or they will give half-life period, they told you to calculate rate constant. Okay, this type of simple reactions are for 2 marks in the annual examination. Okay. So remaining problems we will discuss in the next class.